going to take a revision of half-range Fourier series. Before we start half-range Fourier series, I will just summarize you Fourier series. In Fourier series, we take a function, periodic function from limit minus L to L, and Fourier series of that function is a0 plus summation of Pn cosine pi x upon L from n is equal to 1 to infinite plus summation of Pn sine n pi x by L summation of n from 1 to infinite. And to get the Fourier series, we have to find the values of a0, an and bn and put all that values here to get the Fourier series of the function. So let's find the values of a0, an and bn. So here values a0 is equal to 1 upon 2l integration of f of x dx from minus l to L, and n is equal to 1 upon L minus L to integration of f of x cos n pi x upon L dx from minus L to L, and bn is equal to 1 upon L integration of f of x sin n pi x upon L dx from minus L to L, and we put all these values in above equation to get Fourier series of that function. And we also studied the concept of even and odd functions to get Fourier series easily or eliminate one of a0, an and bn. So if f of x is equal to f of minus x, then the function is even function, and if f of x is equal to minus of f of minus x, then the function is odd function. And the example of even function is x with all even powers is even function, and cos x is another example. Or example of odd function is x with all odd powers, and sin x is with n sin x is another example of odd function. So if function is odd or even, then the value of a0, an and bn are. So here even function, if first we take the function as even, so values of a0, an and bn, if the function is even, then a0 is equal to 1 upon L integration of 0 to L f of x dx, and an is equal to 2 upon L integration of 0 to L f of x cos n pi x upon L dx, and bn is equal to 0. So if the function is even, then we not have to find the values of bn, we have to find only values of a0 and an. And if the function is odd, then the value of a0 and an is 0, and the value of bn is equal to 1 upon L integration of 0 to L integration of f of x sin n pi x upon L from 0 to L dx. So now we can, and if you not understand till now, then go to earlier videos and watch that. You will understand full concept of even and odd function. And here half range, now we can start the half range Fourier series. So half range Fourier series of a function whose limit is from 0 to L. It half range Fourier series concept defines that the function that the range is become half, and in Fourier series we take the range from minus L to L, and in half range we take from 0 to L. So the range become half, and we take an example. We take a function f of x from x is from 0 to L. So half range Fourier half range sine series. So the function f of x is a function from 0 to L, and then half range sine series is f of x summation of n from 1 to infinite summation of pn sin n pi x upon L, and n is from 1 to infinite, and we have to find the value of pn and put that here to get a half range Fourier sine series. So we put we find the value of Bn from this formula. Bn is equal to 2 upon L integration of f of x sine n pi x upon L dx. In Fourier series, we here 2 is not there, and in this here from limit is from minus L to L, and all other is same. And in half range cosine series, we take the same function from 0 to L, and the function f of x is equal to n0 plus summation of an cos n pi x upon L from n to n is equal to 1 to infinite. And n0 here n0 is equal to 1 upon L integration of 0 to L f of x dx. And in Fourier series, that is n0 is equal to 1 upon 2L integration of f of x dx from minus L to L. Means here 2 is there, and the limit of the integration is from minus L to L, and both are is same. And an is equal to 2 upon L and integration of f of x cos n pi x upon L dx. And in Fourier series, 2 upon here 2 is not there, at the place of 2 there is 1, and limit is also from minus L to L. So this is all about our half range Fourier series. So let's take a question, and in this question we have to find half range sine series of a function, and the function is f of x is x, and x is from 0 to pi. So solution. So here we given that f of x is equal to x, and here we replace f of x by x, and limit is by pi. So half range sine series is summation of Pn sine n pi x upon L from n is equal to 1 to infinite, and Pn is equal to 2 upon L integration of f of x sine n pi x upon L dx from minus L to L. So put the values of on putting the values of f of x and L, we got x is equal to summation of Pn cos n pi x upon pi. Here pi is cancelled by pi, and summation is from n is equal to 1 to infinite, and Pn is equal to 2 upon pi integration of x sine n pi x upon pi dx. And here pi is also cancelled by pi, and integration is from 0 to pi. So Bn is equal to 2 upon pi integration of x sine nx dx from 0 to pi. And here we use the multiplication rule of integration or by part rule of integration, in that we decide two functions, and on integrating we put first function as it is, in integration of second minus integration of differentiation of first into integration of second whole integration. So here we find that Bn is equal to 2 upon pi, integrate first function is x, so we put x as it is, and integration of sine n x, and integration of sine n x is cos n x upon n, and that minus is here, and here integration of whole integration here, and differentiation of x with respect to x, and integration of sine nx. So differentiation of x with respect to x is 1, here that is till here that is 10, and 1 upon n is y. Integration of sine nx is cos nx by n, and that is of minus, and minus become plus. So here 1 upon n cos n integration of cos nx, and we know integration of cos nx is sine nx by n, and here n is multiplied by n, and 1 upon n square sine nx. So Bn is equal to 2 upon pi x minus cos nx upon n plus 1 upon n square sine nx from 0 to pi. So here we on putting this limit here 0 pi and 0, we found Bn is equal to 2 upon pi, at the place of x we put pi into cos n pi upon n plus 1 upon n square sine n pi And if we put 0 at the place of x, so here 0 is multiplied by something that is also 0, and the sine 0 is 0, so directly we put minus 0. And here Bn is, this is the Bn, and we know sine and pi is also 0, so Bn is equal to minus 2 upon n, and this pi is cancelled by this pi, so this n take outside, minus 1 upon n take outside, and that become minus 2 upon n, and cos n pi is equal to minus 1 to the power n. And if we take this minus inside this minus 1, so 1 power is added into minus 1 2, so Bn is equal to 2 upon n power of minus 1 to the power n plus 1. So here we put the value, we put value of Bn in the half range sine series. So on putting this value of Bn, we got the half range Fourier series. So this is all about our half range Fourier series. So thank you, and if you have any doubt, please put that in comment section. And if you like this video, please like, share, and subscribe our channel to get more these kinds of videos.